A thermocouple is a sensor that's used to measure the temperature in different items. The way they're made is that two metal legs are welded together to form a junction. At this junction, there's a potential difference that occurs, and this is how it actually operates. When the two junctions are at different temperatures, an EMF is produced, which results in a millivolts. There's different types of thermocouples according to thermocoupleinfo.com. There's base metal and noble metal. Your base metals include types J, K, T, and E, which are all your most common ones, which are used in your basic cheap appliances. Your noble metals types are R, S, B, and N, which are for more higher temperatures, which are much more expensive. The type refers to the different metals used, which in turn gives you the different temperature range and accuracy that it actually reads off. To choose these, some of the things you will consider is the cost of the sensor, the temperature range and limit, how accurate you want it to be, and the durability and what it's actually going to undergo. Here's a diagram showing the different temperature ranges of the types. You can see that we have the noble and the base in different colors, and you can see that nobles will reach much higher temperatures according to this temperature limit diagram. Usually, you want one of the junctions to be at 0 degrees Celsius. This is the most practical way to do this, but it's usually not possible. Instead, there's a law known as the intermediate temperature difference, which is stated as E, the temperature 0, is equal to temperature of the intermediate plus the intermediate at the said 0 degrees. Here's an example of how to use the intermediate temperature law. Here's some examples of type E thermocouple, and it has different temperatures and EMFs that are produced. To find the temperature at 200 degrees, if the cold were to be at 20, you plug in the EMFs and you subtract accordingly. Some of the common uses that thermocouples are actually used for is in your home with different appliances such as your stove, furnace, and toaster. Steel industry uses it to monitor temperatures of molten steel and iron. Manufacturing uses it along electrical and mechanical apparatuses. You can also get power from thermocouples by giving it a constant heat source. To test this, we're going to use a thermocouple along with a multimeter set to DC voltage. When we apply heat to the thermocouple, a EMF will be recorded here. We're going to take this measurement and then graph it and see what the trend looks like. .1. 5.1. 11.4. 14.1. 16.3. 15.4. 15.9. 17.2. 17.5. 17.6. 17.4. 16.9. Here can be seen of our time and the different tests we did. We did 2 tests. There is test 1 and test 2. Test 2 is the data that was recorded in this video. Looking at the graph, test 1 was a little smoother. Test 2 kind of bounced up and then down, which means it wasn't as accurate. But both of them can be seen that they increase in temperature along with the millivolts very quick in the beginning and then kind of taper off towards the end. What this means is as the thermocouple was reaching its max temperature, the voltage started to become a constant value.